Gas chromatography by Marissa, Tori, and Jill. Gas chromatography separates mixtures based on the distribution between the stationary liquid phase and the carrier gas phase. The carrier gas phase, also known as the moving phase, flows through a stainless steel glass column. The stationary phase is a thin film liquid within the column. During the stationary phase, there are two types of columns, a packed column or a capillary column. A packed column, usually constructed of stainless steel or glass, is averagely 2 to 6 meters long, with a diameter of 3 millimeters. This film of liquid is fixed in a small granular particle packed into the column. A capillary column is made of glass and is on average 15 to 60 meters long, with a diameter of 0.25 to 0.75 millimeters. These types of columns can be made narrower because their stationary liquid phase is coated as a very thin film directly into the column's inner walls. When the carrier gas flows into the column, it carries the components of the mixtures which were injected into the column. The components with a greater affinity, which is a natural liking during the phase of gas, moves more quickly than those with a greater affinity for the stationary liquid phase. After the mixture has extended over the length of the column, the mixture comes out as separated components. Retention time, also known as the time needed for the component to emerge from the column from its time of injection into the column, is useful for identifying the characteristics of the materials. Gas chromatography is not considered an absolute means of identification. The reason for this is that another test should also be done to ensure the components of the solution. These substances may have comparable retention times. Gas chromatography is used because of its ability to resolve highly complex mixtures into known components. Gas chromatography is very sensitive to detecting materials at the nanogram level.